Okay, YouTube, this is our first in a series of videos that we're doing in which we are going to actually apply this methodology that we've learned with solving linear systems, that is with two variables or three variables. So what we're going to look at is essentially the key components of every kind of word problem or application problem you solve through with systems and how we kind of set these up. And so I would say that probably the hardest part about any of these is not solving the systems themselves, but just getting the system set up from the word problem. So let's go ahead and take a look at these steps here that I've kind of constructed on my own. So forgive them if they're kind of wordy, but essentially these are the steps that we'll take to work through such problems, and we're just going to keep incorporating these over and over again until we kind of make them second nature. And so let's go ahead and take a look at what I write here, at least for the first step, in which is, if you ask me, the most important step, it's read and understand the problem, followed up by identifying and defining the variables for which we're seeking values. And so in other words, what is the problem asking and what is it that we're trying to find here? And so reading through number one, for instance, let's take a look at this. It says the sum of two numbers is 4. The difference of twice the first number and the second number is -1. Determine the value of these two numbers. And so after reading through this, it seems to me that we have these two numbers here, and what we're trying to do, and this is usually not always, but usually near the last sentence, is what we're trying to find here. And so it says determine the value of these two numbers. And so when you want to define your variables, the very first thing I'm going to mention is that you should always, always, always look for what it is that you're trying to find, because that's what we're going to allow our variables to equal. So for instance here, we're going to say let x equal and let y equal. And since we had two numbers, I'm just going to say the value of the first number here. And then we're going to say this is the value of the second number here. But it is important that before we do anything else with this problem, that we actually define our variables, because what we're going to be doing is now setting up a system of equations in order to solve for x and y. And one thing that I do want to mention here, excuse me, and this is not a universal truth, but it is this: if you have two variables, then traditionally then what we need are two equations in order to solve this problem. So what we're going to do is read back to this problem, and with step C here, we're going to set up equations using the defined variables here and writing x and y instead of number 1 and number 2, and then also use the relationships described in this problem here. And notice I say each equation should have units that match up. Now I'm going to come back to this word units here in future problems, but for right now these are purely numbers, and what we were told were these things. We were told that the sum of the two numbers is 4, and so often what you're going to have to do is from a verbal model write out an algebraic model. And so when we say the sum of these two numbers here, we're really stating that x plus y has to come out to be 4. And so our first sentence, when we read it here, we say the sum, which is the addition of these two numbers, is, which is equals 4. So as we read through the second part here, we say the difference. Now difference, opposite of a sum, a difference is subtraction. So we have the difference of twice the first number. So we're using x for our first number here, so that would be 2x. And we say with the second number, our second number here is y, and this equals -1. And so what we get here is this: twice our first number and a difference with the second number comes out to be -1. And so here's my favorite part. Once you get this system set up, and I'm going to write a little note here that this is our system, what we're going to do is we're going to solve this system here. Simplify any expressions first by distributing or combining like terms, but we're going to solve the system of equations for the values of the unknowns. And you notice I say be sure to label any solutions with appropriate, and this should say units here, but also interpret your results. And so what we're going to do is basically solve this. I noticed that already we could use an elimination method here, addition method. So by adding these together, we come up with a fact that 3x is equal to a 3. So what we've just learned is that x is 1. And with respect to our solution, let's make sure that we write a little space here for our solution. Remember that if we have two variables, we're just going to write an ordered pair. And so we'd say that the x part of our solution is 1. Let's now go back and find the y value. And so because our first equation, if we're going to be looking for y has a coefficient of positive 1, I'm inclined to put it back into this first equation just to keep the amount of work I have to do limited. So subtracting 1 from both parts of this, what we discover is that y is equal to 3. And so boxing this, I'm going to put this over here. But what I want you to notice is once you've found your solution, the interesting thing is I write here, be sure to label with appropriate units. This should say units, but also interpret your results. So in terms of what we just found out here, x is 1 and y is 3, well, looking back at how we defined our variables here, what we could do is we can draw a conclusion from this. And so I'm going to save everybody the trouble of my handwriting here, and I'm going to try to type this in here, but the conclusion we could draw is that x is equal to 1 and y is equal to 3 if these relationships are actually true. And so what I'm going to type here is that the value of the first number is 1, and the value of the second number is 3. And so the last thing, and this isn't always something we do, but we want to do a lot of the time, is go back and check the reasonability of your answers in the problem. So when solving systems, it's always a good idea to go plug this back into the original equations here. And so we would say, does this make sense in the original problem here? Well, I suppose that x plus y is 4. If I were to add these two numbers together, then yeah, their sum really is 4. And if I take the difference of twice the first number, which twice of our first number was 2 times 1, that's 2. If I take that in a difference with 3, then 2 minus 3 is going to be equal to negative 1. So this does make reasonable sense. What I want to do is take a look at just another example here really quickly and throw this together efficiently. So let's go ahead and read through this here. It says, twice the sum of two numbers is equal to 0. The opposite of twice the first number in a sum with 3 times the second number is equal to 10. What we want to do is determine the value of these two numbers. So likewise, the very first thing we're going to do is read through, understand the problem, but we're going to say let this be the value of our two numbers since that's what we're looking for. So the value of the first number here is our x. We'll call this the value of the second number here. So from our variables, what we can do is we can start setting up equations, and we're looking for specifically two here, hopefully, that would be described in the problem. So what we were told is twice the sum of two numbers is equal to 0. So when we say twice the sum of two numbers, it kind of implies that what we're doing first is taking the sum of two numbers and then doubling that. So when we write this out, what it actually looks like is twice of our two numbers added together here, the sum of our two numbers. So we're going to associate x plus y together and say twice that. That comes out to be equal to 0. And then our second equation here comes from the second sentence. It says the opposite of twice the first number in a sum with 3 times the second number is equal to 10. So opposite, well, what's that going to mean? Well, it's going to mean opposite or negative or whatever we say here. So we say negative 2 times our first number, so negative 2x in a sum. So let's see if I can write on this here. It doesn't appear that I can here. But a sum means plus, and we say with 3 times the second number, that would be 3y, we say comes out to equal 10. And so our second equation really here is the opposite of twice our first number in a sum with 3 times our second number comes out to be 10. And from here we get our system. Now, what I said in the first problem here was that we needed to simplify both sides of this equation by distribution or whatnot on part D. And so in this case, you're going to see that we have an equation that indeed we need to simplify here in the first part of it. We could say that the first equation, if we distribute the 2, we get 2x plus 2y is equal to, now we have to take 2 times, oh, sorry, not 2 times 0 here. We're taking 2 times just the x and the y. But we have a 0 on the right side. And then over here we have negative 2x plus 3y is equal to 10. So again, this one was kind of like the first one. It's easy because we've already set ourselves up with addition method here, but it looks like we get 5 y's coming out to be 10. Then we can conclude that y is equal to 2. And if y is 2, suppose we could plug this back into either of our first equations here. I'm inclined to do the second one just so that I don't have to simplify here. We would say that y being equal to 2, we would come up with this equation where negative 2x plus 6 is equal to 10. Subtracting 6 from both sides of this, we get negative 2x is equal to 4, and so x is equal to negative 2. And so in the grand scheme of our problem here, when we want to interpret this, we say, well, what were x and y representing? Just looking at how we've defined our variables here, we represented them as the value of the first number, the value of the second number. So the values of the first and second numbers respectively are negative 2 and 2. Cheers.